Well, hi again. My name is Greg, and welcome to Chapter 13 in my 1949 P3 Rover restoration story. In this chapter, I'm going to cover some work that I've been doing recently on the rear suspension of my car. I'm going to cover really the remanufacture of a welded assembly that's part of the rear suspension. And the reason I had to remanufacture is, would you believe, the original part was a bit rusty. So this chapter will be maybe a little different to some of what I've done before in this series. I'll have a bit more of an emphasis on the actual workshop work and really just how I went about planning making this part. It ended up being a pretty big job, so I'll most probably have to divide this welded assembly remanufacture into two chapters, but we'll see how we go. Anyway, I'll get on with the show now, and I'll probably see you at the end of the video. Okay, bye. This is a diagram from the Rover Sports Registry parts manual showing some of the chassis, rear suspension, etc. I'm just focusing in on the part in question here, so that's the tube which I'm going to remanufacture. Here's the original tube off the car. It doesn't look too bad in this shot, but wait till you see some of the other close-up shots. So this is focusing in on one end. As you can see, it's got an elongated hole there that's not supposed to be there. That's actually a rust hole. I couldn't really ignore the rust issue here because this is a structural part that does take a fair bit of load. Original welded assembly in my vise now. And I'm just going to give a bit of an overview of the whole job. And would you believe it ended up being more time consuming and complex than I expected, but that's alright. I kind of enjoyed it, to be honest. So I'll just go through how I kind of figured out a way of reproducing it. So I'll just have a bit of a scan overall here. I've made a few changes to the original. I mean, I've chopped off a section on the end here, and I did cut through there and also through here, and I've sort of tack welded it back together again now. The reason I did that is I wanted to sort of separate it into sort of component parts. So as a way of making it, I've decided to separate, actually I might go to the other end, it's a little easier. So I decided to separate this sort of bracket structure into three main parts. So this big end plate, a top plate, and then a small end plate. Now when it was originally made, I kind of assumed this stuff would have been stamped out on a press. So this top plate and side plate were one piece, and you can see they've been welded together there. It was a little hard to reproduce that, so as I've explained, I've done it in three parts. I use this hole to my advantage in certain ways as well. So when I was making the top plate, I made a form tool like so, with a locator pin in it that located on that hole. So this form tool just forms the rounded edges that are part of this top plate. I also use that hole to my advantage when I'll just put this on here. Because I was making this as three separate parts, I had to be careful to get the angle that this top plate was welded to at in relation to other parts of the bracket structure. So I made this, I guess you call it a setting tool, that gives me that angle. What else did I make? I made a very crude setting tool also to get the angle of this bracket in relation to that face correct. Worked pretty well for me though. So in the rest of this particular YouTube, I'm just going to go through I guess in reasonable detail how I made all these component parts, actually including the bracket that sits on the end here, which is a bracket actually for the exhaust system. Here I'm starting to cut the tube to length on my milling machine. I'm using a cutter known as an end mill. This one is a fairly old one that I would have salvaged from my workplace many years ago, therefore it's a bit blunt. So I'm taking it fairly slowly and using a bit of cutting lubricant. I chose to use this cutter because it's a nice length, and I'm able to do the whole face of the tube in one pass. I've turned the tube around now. I'm milling the other end so I can mill the tube to its final length. I had to use a tape measure because that's the only measuring tool that I had that would measure something of this length. Next I'm going to cover how I made the plates that are part of the bracket assembly, starting with the small end plates. Hi again. Well, the task at hand right at the moment is to make a big hole in these plates. So I've got two plates clamped together. I don't know if you can see that. So basically what I want to do is make this hole in both of them at the same time, just for a bit of efficiency. The hole has to match the diameter of this piece of tube, so this piece of tube will fit through the plate and then be welded in place. It'll become clearer as we get further into the process. So what I'm going to do is I'm going to use this edge finder to find this edge and that edge, and then I'm going to come 1 1/8 of an inch from that edge and 1 1/8 of an inch from that edge, and that'll be the center point of the hole. I'll drill the hole out as big as I can. I don't have a drill of that diameter, so the finish hole size will be done with a device called a boring head. I've got my boring head here. I'm just looking through some of the tools that I could use. I've got this boring bar which I can fit to it. I made probably when I was an apprentice fitter and turner in the 1970s. I think I'll use this boring bar, which is an old milling cutter which I've ground to make use of it as a boring bar. I'll use this one because it's shorter and stouter, and I don't need the length that I can get with that one. As a general rule of thumb, you know, the shorter and more rigid it is, the better, because you'll minimise vibrations. The largest diameter drill that I own now fitted to my milling machine. It's a 30mm diameter drill, which is still less than that I want for finished size, but at least it gets most of the hole done. And as I said before, I'll do the finish bore with a device called a boring head. So we'll start her up. I think that's probably fast enough. I might even go a little slower than that. I think it's probably going to make a bit of noise because of the, it'll set up a bit of vibration, but not much we can do about that. I've sped the video up by 8 times here because I guess it's not a really interesting process in real time. Got my boring head fitted now, along with my little boring bar. So here we go. That sounds pretty good. It's nice, smooth cutting sound. And getting a nice sort of steel ribbon coming off as it cuts. So it's all cutting quite nicely. I've sped it up to reduce some of the boring time, if you'll excuse the pun. Okay, I'm getting pretty close to finished size now, so I'm going to measure it accurately. I'm going to use a device called a telescopic gauge, which I've got here. The telescopic gauge is like a spring-loaded gauge that you can lock into position once you've got it into the largest part of the bore, and then measure using a micrometer. Well, I've measured it, and it should take just 24 divisions on here. Each division on here is 0.01 of a millimeter. Okay, I've unlocked this. I'm going to move it the required amount now, so it's 10, 20. I'll take it all the way out to 24 divisions. We'll lock it up at that. That's beautiful. It's two 1/100th of a millimetre smaller than the diameter of that. So I'll continue to just take very light cuts until I get a nice sort of sliding fit on there. I've taken a light finishing cut now. I'm just trying it out for size, so to speak, and it fits quite nicely. It just slides in fairly easily. Perhaps a little looser than I would have liked, but that'll probably work to my advantage when I come to put it together. I'm doing the bigger of the two plates now, so it's a shape that looks a whole lot like that. I'm not sure how well you see that on the video. I've worked out the dimensions and using that face as a reference face and this end as a reference face. So the big hole here, for example, where the tube goes through, that's 1 1/8 inches from that edge, and 1 1/8 inches from that edge to get to the centre. Then I've worked out the dimensions of all the other holes. So what I've done is, for the two plates, I've temporarily sort of tack welded them together so that I can do two together. Just much more time efficient that way. And when I actually do the final work on them and cut them to shape, or all these tack welded together sections are cut off anyway. Just using a little centre drill to start each of the drilled holes now. Here's the screen of my digital readout. As you can see, there's an X and a Y axis there, which gives me a very accurate readout on how far I've moved the milling machine table in either direction. And in this way I can use the readout to position my holes very accurately. I've come across to the second hole, which is 3.8125 from that edge and 0.375 of an inch from that edge. So I can get this very accurate now. All holes are centre drilled now. I use the centre drill because it's just a more accurate way of starting the hole. Done. Here's the two larger plates still tack welded together with the large bore hole done now and the other holes drilled. So I've got it on the table of my bandsaw now, about to cut it to shape. Almost finished now. Now, prior to cutting off the last of the tack welds that were holding the two plates together, I've used the bolt holes to bolt the two plates together so that I can just continue to cut and shape them both at the same time. This is the shot of the end plates, large and small, ready for welding assembly. I forgot to take a photo of the top plate, but you'll see that in the finished photos anyway. Also had to turn up a couple of little bosses, like the boss you can see in this shot, welded to the small end plate. That was then threaded. You'll be able to see what that's all about when we get to the sort of final assembly point. Working on what is the last sort of component of this bar now. So there's a bracket here that sits on the end. I've flattened out a tab on this side that used to be bent up the same as it is on this side. So I'm basically trying to copy that now, and then I'll weld that onto my reproduction bar. This is the sort of beginning stages of what I've done. So I've bent 90 degrees there, and I've done a cutout here to match the original. Next step will be to tidy that up a little bit, file it, and then I'll bend this section over, that section over, then I'll have to cut radius through here so that it fits around the pipe, and then weld it on, and then I'm done, I think. Pretty straightforward operation here. I'm just heating up the steel with a blowtorch to make it a bit softer so it's easier to bend, and then beating it with a hammer to bend it. This little bracket pretty much finished now. I've got it bolted to this heavy bit of steel for a couple of reasons. One, when I come to weld it onto the main bracket or main tube rather, it'll help to stop it from distorting, and two, having it mounted on this piece of steel helps me to set it at the right angle in relation to other bits of the assembly. Just positioning that little bracket now at the end of the tube, as I mentioned in the last slide. This is skipping a fair way ahead and really probably encroaching on stuff that I'm going to cover in the next chapter. But here's one end of my remanufactured tube showing that bracket and all the plates welded together. And I must say it's looking pretty good. Hi again. With this I'll wrap up chapter 13 of my 1949 P3 Rover restoration story. I'll try and get chapter 14 out as soon as possible, where I'll cover the welding assembly of some of the parts that I showed in chapter 13, and I'll also cover some of the manufacture of some of the peripheral parts that were part of this rear suspension tube. As always, I hope you found this chapter interesting and informative, and I'll see you next time.